All right, so page 93, you'll see these triangles here listed for you. There's no questions there. Again, I'm not a fan of some of their formatting issues. It's going to ask you 2 questions on the next page. I would just like you to see if you could answer those 2 questions, and then we'll go through them. So I'll leave this up so maybe you don't have to flip back and forth. Turn to the next page, look at the questions, see if you can answer them. Pretty much have to understand number 1 to get number 2.
Squared.
Yes. If we're talking about Einstein's theory of relativity, can you tell me what all those letters stand for?
Those letters are
No, equals MC squared. If you're gonna use that, you gotta tell me what it is.
energy equals mass. Mass and then C, I forgot what C is, but I know it's energy equals mass.
Speed of light. 3.0 times 10 to the 8th meters per second squared. So if you're gonna use that, you gotta know what all everything means. All right, first question. It is asking us the length of BE. So in order to do that, I'm gonna break this up into 2 triangles. I see the little guy here. All right, that's the one it's asking me for, is this length. Let's compare it to the large one. We know they have to be similar because they share the same slope. So the little side here is 2. What's the length of the whole bottom? How far is it from A to C? 4, right? Look at the x coordinates. So how much bigger is a big triangle?
Pretty big.
Double. 2 times 2 is 4. It's double the size. So let's figure out what this is. How far apart is this side of the triangle? Ian? 5. So then from that, I should know the length of BE. Because you said it's twice as big as the little one. 2.5, yeah, 2.5, absolutely. So BE is 2.5 because it's half as big. So knowing that it's 2.5, right, I should be able to give the coordinates of E then. It's not going left and right at all, so the x coordinate is still 2, just like this one is. It's right above it. What's the new y coordinate? Wyatt, what's the new y coordinate?
Oh, it's like this wouldn't be like half a 7, something like this.
No.
Oh,
I mean, the y coordinate is 2, so it's up 2 here, right? And you said the length is 2.5, so I'm asking what's 2.5 above 2? 4.5, yes. So 2 and 4.5 or 4.5, that would be fine as well. All right, what we mean by an equation of a line, page 95. Line J is shown in the coordinate plane. What are the coordinates of B and D? Gavin, what's B?
B is 3, 4.
3, 4 is right here.
3.
4, 3. Remember the x coordinate comes first, so 4, 3. And D. 8, 6. All right, let's back up a little bit when we talked about the slope, right? How far up and down, how far left and right. So this one would be 3 up and down and 4 over, so that would reduce to 3/4. Vertical, rise over run. Where if I make the big triangle all the way to D, now it's 6 up and 8 over from the origin, 6 up and 8 over. And notice that would reduce to 3/4 as well. So now the question is, 2015, is that on the line? Well, since we're starting at the origin, notice on the first point, it was just 3 over 4, right? 3 over 4 would give us 3/4. 6 over 8 would give us 3/4 as well. So let's do the same thing for this one. The question is that 3/4?
Yeah.
Yes, it is. What'd you divide by to get 3/4? Divide them both by 5. So yes, it is, because it reduces the same thing. How about 175? Well, check that one. Same process. Claire, what do you think? Is there a number that goes into 75 and 100 that we could reduce it?
Yeah.
What? 25. What is 75 divided by 25? How many quarters does it take to get 75 cents? And how many to get a buck? Yes, so that is the same as well. $68 over 90. Let's see, they're both even. So I know 2 goes in there. I don't think I can get any lower than that. So certainly it doesn't look like it's going to work for me. It doesn't reduce to 3/4. And no deal on that one. So number 5 says, write a generic rule of what we just did. Well, if you have a point xy, all we have been doing is putting y over x to see if it equals 3/4, or 0.75 if you want a decimal. That's all we've been doing for that problem. That would have been our rule. Page 96. Here are 2 diagrams. Again, it's got some information already filled out on there. It says complete each diagram so all vertical and horizontal segments have expressions for their length. So let's do one of them together. Okay, so every horizontal expression and vertical expression. So I need to know this length and this length. So what point do we have for F? C I can tell. C is 8, 4. All right, so what point is F? Well, it's 2 points something, right? I would have to guess. But it is going to have the same x coordinate as this one. So whatever E is, this is lined up with it. So F has to be the same. So I'm going to label it the same. I'm going to put an X there. Y coordinate, how high is F? How do you know it's 1? Yeah, it's got to be the same as this one, and it tells you it's nice on that line right there. So to get this length, I would have to subtract the y coordinates of both of these. Okay, just to show you how that works. If I wanted to know the length of this one, I would take 7 minus 4. That's how I get 3. I'm going to do the same here. The only thing is I don't know what letter or what the number is, so I just got to use y. So the length of EF would just be y minus 1. Again, that's not a nice answer, but it depends on what that y coordinate is, and I don't know. So how would I get DF then? How do I get that length? Well, if you look at the one that's already done for us, why is it 4? Well, because I subtracted the x coordinates. X minus 4 gives me 4. So what are my x coordinates here? Well, my x coordinates are x and 0, so I'm just going to write down x minus 0. Depends on what that x is. So that's what it is looking for. And until I know what x and y are, I can't even give an answer. It would need more information. So I'm just going to leave them just like that. I would like you to do the same thing that we just did to this triangle up here. See if you can tell me what this length is and what this length is. Doing the exact same thing we just did on the previous page. I'll give you a minute or so to do that. All right, so first we need to figure out what f is. Again, I don't know what the x coordinate is, so I'm just going to put x because it's got to be in line with E. How far up is it? I know it's at 4. So that's your first step. Write the coordinates of f. Length of EF then, I just look at the y coordinates. I'm just going to subtract them. Y minus 4. And to get the bottom one, I'm going to subtract the x coordinates, the first numbers of the coordinates, x minus 2. And that's all I can do. Question number 2, can you write the equation of the similar triangles? All right, let's do this one first since we're on this page. The vertical segment of the little triangle, how long is the vertical segment? The one going up and down of the little triangle. Parker? We just found it. How long is this part right here?
That one was about 2.
What?
Y4.
That's a minus.
Y negative 4.
Y negative 4, yes. Minus, subtract, any of those would work there. I'm going to give you another shot. Ready?
Okay.
Horizontal segment of the same triangle.
X negative 2.
X negative 2, yes.
Ooh.
All right, you're on a roll. I'm going to keep asking you. Big triangle, vertical segment.
Big triangle. Is it
It's
X
not showing.
Is it X4?
On this triangle? The part going up and down on this triangle.
God's
3.
Yes, yes, it's a 3. Horizontal, same triangle.
4.
Yeah, see, now you got it, right? Okay, we're gonna do the same question on the other one on page 96. This was page 97 triangle. Page 96, it's on your left side there. I'm gonna keep this here, Parker, so you can't look at it. Gotta use your book. Little triangle, vertical segment, Adam.
X is Y negative.
Y negative 1. You guys are just don't like the minus. Want to just say negative. That's fine. Horizontal segment.
Oh, shoot.
Nope, not that.
Oh. That X minus 0.
Yes, x minus 0. Technically, I suppose we could just say x because minus 0 isn't going to change anything, but I'll put it in there. Vertical segment of the big triangle.
3,
Horizontal segment of the big triangle.
4.
Parker, look good?
Yeah.
Yes, yes. There you go. That is just writing similar triangles, a vertical and horizontal of each one.
I'm not ready for more.
You're not ready for more? I'm kind of thinking we could get that.
Oh.
Yeah, we're gonna do it.
easy.
A little hint here. Area of a rectangle is length times width. Area of a triangle, remember that formula?
Length. No, base times height divided by 2.
Yeah, base times height divided by 2. I'll give you a minute, see if you can find the area of all those pieces.
What?
You like waffles.
What?
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 My tongue twist can't stop.
It's like third grade stuff. Oh, there's 2 questions.
Stop looking at me.
All right, hopefully you got a good start on it. I want to give you plenty of time to work on your homework, so let's go through it. Find the area of the shaded region by summing the area of the triangle. So if I find out all the area of the triangles, I just add them up here. 5 times 10, remember to divide by 2 because it is a triangle. What's 5 times 10 divided by 2? 25, so the area of this one is 25, same as this one. Area of the big one, 24 times 15, that's 360. 360 divided by 2, it's 180. So if I add up 180, 25, and 25, I should get 180 plus 50, 230. Question number 2. Find the area of the shaded region by subtracting the area of the unshaded from the large triangle. So we need to find the area of the big triangle. Like this piece was not missing. Okay, so let's say that piece is not missing. This is obviously 24. So the whole bottom is 5, 5, and 24 is 34. That's my base. My height is 15 plus 10. 25. So if I was to find the area of the triangle, I'll cheat here for you.
425.
You already got it? 34 times 25 is 850 divided by 2 is 425. That is not the area of the whole thing though, because I got a piece missing. This is not shaded. What is the area of the piece that's missing? Minus 240. $185. $185. So the question is, what's going on here? How come it doesn't add up to 1? Okay, because 1, all I did was add up all the blue pieces, and for number 3, I added up the whole thing and subtracted the piece that's missing. Why aren't they the same? Well, the whole point is just because a triangle looks similar doesn't mean it is. That figure actually cannot exist as it's labeled. Okay? It might look similar, but it is not. They just have them lined up that way to show you. So these triangles are not similar. These triangles do not have the same slope. They just made it appear that way. Because if they are similar, these two answers should be exactly the same. So don't let your eyes deceive you and just say they look similar. That is the point of that question. All right.
So not cute.
Page 101. Your homework, I just want to point out to you that I'm sorry about the formatting on number 2 again. But look how many times you hear the word explain, right? Explain, explain, explain. On 2, on 3, just make sure you do so. If it says explain, make sure you answer that. So just 1 through 4, guys, for tomorrow, lesson 11.